The first thing that we need to do if we're going to work to find an arithmetic or geometric sequence is to determine if the sequence that we have of these first three terms are given to us, if we're adding or multiplying by something to get the terms. So first we do a test to see if it's arithmetic. Are we adding something? So if I take the second term, which is a 12, and I subtract the first term, I get a 7. If I take the third term and I subtract the second term, I also get a 7. So there's a common difference between one of these terms. This is repeatedly adding 7. So we call that a common difference. If this is our a sub 1 term, I need to find the a 48th term, but since I already have the first one, I'm only going to add 7 47 times because this is the first one. If I go from here to here, this is a sub 2. I only added 7 one time to get here, even though there's two terms. So in coming up with a formula, we'll say that a sub n is equal to the first term, a sub 1, plus, and then what we want to do is we want to do n minus 1. So if I want to find the 48th term, I really only want to add 47 times. And this is going to be times the common difference, which is 7. So I want to find the 48th term. And what I'm going to do is I'm going to add the first term to, this is going to become 48 minus 1. So this is 47 times 7. So I'm adding 7 47 times to the first term to get the 48th. So 5 plus, this is going to be 329. Then I'm just going to add these for the next line. So I get 334 is going to be the 48th term. Let's try another one, and after you practice it a few times, it'll get easier. So this time we're seeing decreasing numbers in our sequence, and it works the same way. To find the difference between these two here, what would I have to add to 60 to get this one? In this case, if I did 360 minus 353, I would get 7. And to go from 353 down to 346, I'm again changing by 7. But instead, our common difference, instead of adding 7, we're subtracting 7, but we are still adding a negative number. So we again put down our formula, which is a sub n equals our first term plus n minus 1 times the common difference. A sub n, we have to find the 40th term this time. And then our first term is 360 plus our n number is 40, but I've already got the first term here. So I do 40 minus 1, which is 39, times minus 7. Common difference is negative, so we're adding a negative number. Coming down to the next line, we have 360 plus, when we multiply this, we get minus 273. We're adding a negative number, which is the same as, of course, 360 minus 273, which is 87. So here we have a sequence of 3 numbers, and we're asked to find the 8th term. And we need to first do the test for arithmetic to see if it's arithmetic or geometric. So first thing I'm going to do is 66 minus 22, that's 44. And when I do 198 minus 66, I get 126. So this is not adding the same thing 3 times. So what I am doing, going from one term to another, this is times 3. And 66 times 3 is 198, so this is times 3. So what we have, they don't call it a common difference when it's a geometric sequence, they call it a common ratio. Now, common ratio is a repeated multiplication, so I'm doing times 3. So I have some number here, which is a1, and then I want to multiply by 3, and I want to multiply by 3 a repeated number of times. If this is the first term, this would be 3 to the first power. Then I have 3 to the second power, third, and so forth. So if I'm asked to find the eighth term, well, this is the first one. This is my 3 to the first power. So I really only need to do it 7 more times. So in coming up with the formula, the nth term of our sequence is going to be equal to the first term of the sequence times the common ratio raised to the n minus 1 power. We have a sub 8 equals the first term, which is 22, times the common ratio of 3 raised to the n minus 1 power. So the reason that I want to do 8 minus 1 here and raise this to 7 is that this first term had a prior term also, and this first term was had by multiplying by 3. So this is 3 to the first power times 3 to the 7th power, which gives us the repeated multiplication to get us to the 3 to the 8th power. So continuing on, our next line, we have a sub 8 equals 22 times 2,187. And now I have to multiply these two, which is 4,814. And this would be our eighth term. Here in this sequence, we notice that the numbers are decreasing. The first thing I want to determine is, am I adding a -5? To go from 10 down to 5, I add a -5. And to go from 5, adding a -5 would have put me at 0. So this is a geometric sequence. So what's happening to go from 10 down to 5, what I'm doing is I'm multiplying by 1/2. We don't say division for a geometric sequence. I'm not dividing. What you're doing is multiplying by the reciprocal. So to go from here to this, I'm also multiplying times 1/2, and 5 over 1 times 1/2 is 5 over 2. So our common ratio is 1/2. So we go to our formula, which is going to have the repeated multiplication. The nth term of our sequence will be equal to the first term times the common ratio raised to the n minus 1 power. And since I want to find the sixth term, I have a sub 6 equals 10, which is our first term, times the common ratio of 1/2, and all of that raised to the 6 minus 1, and that's going to be raised to the 5th power. So this term already has been multiplied. Its prior term would have been 20. 20 times 1/2 is 10. 10 times 1/2 is 5. Now, since I have the first term, I need to find 5 more terms, which is why this n minus 1 is 6 minus 1, giving us a 5. Now, when I multiply, I have a sub 6 equals 10 times. Now, 1/2 to the 5th power is a 1 in the numerator, and 2 to the 5th power is 32. And now to multiply this, I get 10 over 32. And depending on, you can either reduce that or you can just check on a calculator what 10 divided by 32 is. You get 0.3125. So our sixth term is there.